Welcome to Section 11.1, Understanding Area. Our objective is to understand the area of rectangles and squares. For homework, we'll be working on page 513 to 515, numbers 1 through 17. So first, we have to actually understand what area is. Area is the number of square units inside a closed figure. So as long as we have any type of shape, so in other words the sides are going to be connecting and there's no sides overlapping, we can find out what its area is, which is the amount of space on the inside. So our first formula, which hopefully we already know, is the area of a rectangle. The area of the rectangle is length times width or base times height. Anytime we do have a rectangle, we want to make sure that we always find the right angles, where one of the legs is going to be the length or the base, the other leg is going to be either the width or the height. Our next formula is the area of a square. The area of the square is sides squared, or length times width or base times height, knowing in a square the sides are congruent. Okay, next important concept. It's important to note that every closed region has an area. So again, as long as it's closed, you know you can find its area. Next, if two closed figures are congruent, then their areas are equal. So if we have congruent triangles, they'll have equal areas. And last but not least, if two closed regions intersect along a common boundary, then the area of their union is equal to the sum of their individual areas. Now, here's what that means. That last property that you have says if we have something irregularly shaped, we can chop it up into other little pieces and then add up the different areas to find the area of the irregular shape. So here's our first example. We're going to find the area of the rectangle. Now, we know in a rectangle we're going to have right angles formed at the corner. The length and the width we need are going to be the legs that form that right angle. Now, we know one of the legs here is 15. We need to find out what the other leg is using Pythagorean's theorem. X squared plus 15 squared equals 17 squared. So x squared plus 225 equals 289. Subtract your 225 to both sides. X squared equals 64, and when I square root that, x equals 8. So to find the overall area of the rectangle, we're going to do length times width, or base times height, whatever you want to call it's fine. But it's 8 times 15, which is going to be 120 square units. If it says feet, we'll do square feet. Inches, square inches. If there's no units labeled, we're just going to call it square units. Here's our next one for you to try on your own. If the area of the rectangle is 80 square inches, find the value of x. Take a second, push pause, and let's see what you can do. So here we go. If area of a rectangle equals base times height or length times width, let's plug in our pieces. We know the area is going to be 8, we know the base is 5, and the height is x. If you interchanged it, that was fine. Divide both sides by 5, and for our solution, we're going to be left with x equals 16 inches. For our next example, we have an irregular shape. So we want to find the area of the inside here. So here we go. We have two options for how we can solve this. Our first option is we can actually look at this as being a big rectangle. So what I want to do is I'd want to continue this side up, connect it over, and do the same thing down below. Now, this full side here would be 8, as would this side be. My full side down below here, or my full side across here, depending on how you're looking at it, is going to be a total distance across of 11. So the area of that whole rectangle is going to be 8 times 11, which is 88. Now we have a problem. There's a piece that's not supposed to be here, and a piece that's not supposed to be here. All we would want to do is subtract both of those pieces off, and we're subtracting off the areas. So I'd be subtracting 4 square units from here, and 8 square units from here. When I subtract both of those off, that's going to give me with a total area of 76 square units. Now, there's a second way that we can do this. So again, here's our picture again. What we could actually do is we can break this thing up into different squares or rectangles. What we can do is draw a line going there, a line right here, and a line right here. And we would want to find out what all of those different areas are. So our first one, we have a height here of 6 and a width here of 7, which gives me a total of 42. The total distance across is 7 plus 2 plus 2, which is 11. Now, we're already 2 units in here, so what's left for this one is going to be 9. We have a 9 by 2 rectangle, whose area here is going to be a total of 18. For our next one, we have 2 for our base, and this one goes up 4, so it starts at the 4 point, and it has to meet this other line, which is where the 6 line goes. So it leaves me with 2 units going up. A 2 by 2 square gives me an area of 4. And last but not least, we have 2 units across and a total of 6 units going up. That's going to give me a total of 12. So here we go. Let's add up all those individual areas. We have 42 plus 18 plus 4 plus 12. So let's add that up. 2 plus 8 is 10. 10 plus 4 is 14. 14 plus 2 is 16. Carry the 1. 1, 5, 6, 76 square units. Now, for this problem, I definitely would have chose our first method. Although the second method works, we got a lot of different pieces that we're dealing with. This is the least efficient method for this problem, although depending on the problem that we're looking at, it might be best to break up your pieces. And here's our last example, one for you to try on your own. I want you to find the area of the shaded region, so just the distance around, almost like a pool deck. Press pause and let's see what you can do. So here's the way that I thought of this. I thought of this as being a rectangle that's all the way shaded in, but then we want to subtract out that middle piece. So the first thing that I did is I found the area of my big rectangle, imagining everything being shaded in. Well, 8 goes from here to here, and then we have 3 units on either side. So 3 plus 8 is 11, plus another 3 is a total of 14 up. We have 3 going across, followed by 30, followed by another 3 across, which gives us a total of 36. So let's find the area of that big rectangle. We have 36 by 14, which gives me an overall area of 504 square units. Now, the area of that small rectangle that I want to take out, we have an 8 by 30, which gives me 240. We want to subtract that out, and we're left with 264 square units. And we're set. Here's the answers to our homework. Again, we're in section 11.1, and for homework we're doing problems 1 through 17. If you have any questions, please make sure you ask them tomorrow, and as always, have a good one.